Hi everyone, this is the demonstration video of task 8.1D of SIT 210. In this task, we need to build the I2C communication between light sensor and Raspberry Pi and to display the light intensity. I determine the light as too dark, bright, dark and too dark, taking these values as base.
Before jumping into the video, let's get to know more about the I2C communication. I2C, which stands for the Inter-Integrated Circuit, is a widely used serial communication protocol in electronics and embedded system. It allows multiple devices to communicate with each other over a shared two-wire bus, consisting of data line, that is SDA, and a clock line, that is SCL. I2C is known for its simplicity and versatility, making it suitable for connecting various sensor, display, memory devices, and other integrated circuits in a wide range of the application. It operates as a master-slave protocol, where a master device initiates communication with one or more slaves devices, enabling the bidirectional data transfer at relatively low speeds compared to the other communication protocols. In this task, Raspberry Pi act as an master and BH1750 light sensor act as a slave. The double-headed arrow is the line to send and receive the data, and the single-headed arrow is the line that carries the clock signal, which helps in synchronizing the data. Now let's see the hardware part of this project.
As you can see, this is the BS1750 sensor and its VCC, ground, SDA and SCL pin are connected to the pin number 1, 6, 3 and 5 of Raspberry Pi. The I2C communication is established using two wire or we can say pins, that is the data pin and the clock pin. The data pin stands for the SDL and the clock pin stands for the SCL. The data pin sends or receive the data and the clock pin, that is HCL pin, synchronize the data. Now let's see how it works. As you can see, the current lux value is around 67, which is showing that it is too dark. As soon as I turn on my desk light, the lux value turns to 487 around, which is showing that it is too bright. And as I block light around the sensor, the lux reading changes and the message will also get changes respectively. The message changes as bright, dark and too dark. Now let's see the software part of the code. So this is the software part behind this project. These line imports the necessary Python libraries, assembles for I2C communication and time for time related functions for putting delays. Next, this part of the code. Here I defines some variables to customize the program. Interval specifies the time interval between the consecutive light levels readings. Too bright, bright, medium and dark are brightness level threshold in lux unit used to categorize the light level. Next, in this part of the code, the light sensor is set to the I2C address 0 by 23. It represents the 8-bit address of the light sensor, that is BS1750. Continuous high res mode specifies the mode for continuous high resolution light level measurements. The SMBus.SMBus1 initialize an I2C bus instance using the DAV I2C1, which is the default I2C bus on the Raspberry Pi. It allows the communication between the I2C devices. Next we have this part of the code. Here the get light reading function retrieves the light level readings. It writes the continuous high res mode to the light sensor to initiate a measurement. It waits for the measurement to complete with 0.2 seconds delay. It reads 2 bytes of the lux data from the light sensor. It converts the lux data to the lux value using the formula using this formula, as you can see here, using this formula from the BH1715 datasheet, the lux value is gets returned. Next we have this part of the code. The get brightness ranking function categorize the light level based on the lux value. It checks the lux value against the predefined brightness threshold. Too bright, bright, medium and dark. Depending on the lux value, it prints the current light level and returns the corresponding ranking as a string. Next we have the main function. The main function is the main part of our program. It runs in an infinite loop. because I write here while true to continuous monitor the light level. Inside the loop, it calls the get light reading to get the current light level. It calls get brightness ranking to categorize the light level and print the result. It introduces a delay of interval seconds between readings. And the this is the last part of the code. This part of the code calls the main function as I run the code. So this is the overall demonstration of the hardware and the software part. Thank you.